Okay, so basically for this class, we break it down into H module because you have H week, right? You have H week, we break it down into H module here. And now to start with H week here, the first thing I strongly recommend you go over the announcement because that is the most update information, right? So if anything come up, I will update in the announcement. The second thing here, I strongly recommend you go over to the learning activity. Right? Learning activity. Which one? Yeah. The second thing I want to go over to the to the start of the every week here, you go with the learning activity, right? So in the learning activity here, you have something strongly recommend you go. The first one here, right? You have to read the chapter number 1 about overview of computer system and programming logic. The second one, right? You read the PowerPoint here, and for the PowerPoint here, actually I spend my time to modify a lot about the PowerPoint. I integrate some of the useful information, some of the slide, and some of the program also, right? I include the Python and some pseudocode and flowchart in the PowerPoint here. So it's really helpful for you to reference to work with the assignment here, right? So the two things strongly recommend you before you starting with every here. The first thing, you read the chapter in the textbook, right? You know that how to access the textbook, right? So think about this one here. If you want to go over the chapter number 1, overview of computer system here, you go to the chapter number 1 here, right? You click on the link and you read everything in the chapter number 1, right? That's the second thing. Huh? The second thing, you go over to the learning activity here about the PowerPoint, right? So I have the link here. You just click the link here and download it. You have the PowerPoint for this one, right? So that's the first thing, right? So when you're done with everything with reading here, you can go over to your assignment. You can go over the assignment. So in the assignment, you have some type of assignment here. The first one, discussion. So remember that for the discussion here, actually for every discussion, you have 2 due dates. Remember that we have 2 due dates for every discussion here. The initial report, you are supposed that you have to submit no later than Thursday. Right? So when you submit your initial report here, you make sure you have to follow up with the other student. You have to make sure you follow up with the other student here, and you reply at least to the 2 other students here, right? So basically, I made it in the announcement here. I made it in the announcement here, right? Oh, not yet. Yeah, but I will make it later on. So let's make sure that for every discussion you have to do that. Make sure that for initial code you upload it before no later than Thursday, right? And after that you follow up and reply at least to other students on Sunday. Okay. Now that the one type assignment, the other thing that you have some activity on in-class activity, and later on I will give it to you later on here. And for this week, you have to make sure you install and something about Dryo. I show you how to go to Dryo and how to download and install it already. Right? You have to make sure you download and install the Python and GitHub. Right? GitHub anyway is optional. W, right? And you also we have the some of the for this assignment. The second one about the using the pseudocode and flowchart, I'll go with you later on. Okay. So the first step here, I want to go over to the chapter number 1. The chapter number 1 is about overview of computer and programming here. Overview of computer programming. Okay, so in this chapter, we learn about computer system, simple programming language, step involved in the programming development cycle, and pseudocode statement and flowchart symbol using the sentinel value and program and so on. I will go over all of them here. Now, first about the computer system. So the first I want you to understand what is a computer system. So basically the computer system is a combination of all the components required to process and store data using the computer, right? So now tell me, what do you do with the computer? What you use the computer for what? Now tell me, what some reason here? You play game or what?
Play games, write papers.
Yeah. So basically for whatever it is, if you play game or write a paper, what you need here, you need to do something about the process here, right? Because you give information to the computer will do the processing here, right? And giving you the output. Okay, so basically the computer here, they break it down into two categories. The first is the hardware. The hardware is anything about physical equipment. You can see, right? Visualize here. It's about the desktop, about the screen here, about the CPU, about the speaker and keyboard and mouse here. Everything about the hardware, right? The software here, it is an instruction about the program here, right? The computer instruction that tells the hardware what to do, right? So basically in the software, it break it down into the program and the programming here. So what is the program? Program is an instruction written by programmer. So the program, you can think about program, it is a kind of the software here, right? Think about you have the Photoshop, you have the Microsoft Word, it is written by someone already, by programmer already, and you are the one who uses it, right? Okay, and the programming here, it is a process for you. You learn it now, how to write the program, how to develop program here. Okay, so basically for whatever it is, the computer hardware and software, the only it completes the three major operations. The first thing is input, right? You have the computer here, you have to give it some data. So what? How can you give the computer by the data? What is the input here? How can you give the input? By click the mouse, right? By click the mouse, by using the keyboard. You have many ways to give the input here, right? So basically, for every process of the computer here, you have the three major operations. The first one is input. It's a data item such as text, number, image, and sound, and you can use it by mouse or by keyboard here. Right? So when you get the input for the computer, you do the processing. The computer is the one who does the processing, right? It do everything, it's a calculation and comparison. It's performed by CPU. CPU is a central processing unit, and it's the brain of the computer. Right? You do everything about the processing here, and later on, when you do you have the output here, right? You have the resulting information that's sent to the printer, a monitor, a storage device after the processing here. And nowadays, cloud also very popular, right? You not only store it in your computer, but you can upload in the cloud and you can access it from anywhere. Okay. So back then for the computer architecture, back then before the von Neumann here, right? Before his guy here, computer built on specific time. That means if you have the specific program, you have to build for specific computer. And actually, before it's a huge computer. It is the size of the building here. A lot of the vacuum tube and a lot of things here, right? So it is a specific for task and program are hardwired into the computer, right? And if you have another program, you have to rebuild. You have to build another computer, right? So basically, back then, before the von Neumann architecture here, you have specific hardware for any specific program here. Okay. Now, who is John von Neumann here? It is Hungarian American mathematician and physician here, right? And it's a member of Manhattan Project. And what he introduced here? He introduced the von Neumann architecture. So basically, for von Neumann architecture, they generalize the process of the computer, right? So basically, you have the input, you give the input to the computer, right? And you have the central processing unit here, and you have memory unit, and you have the output device. So they just have the open standard. From now on, every computer, right? You have process of giving the inputs here, you do the processing, and you take it out the output here. Or you can store it into the into the storage here, right? So basically, for every device here, the first thing you have the input and output here, right? That's the device that allows computer to interact with the outside world. It can be the keyboard, mouse, touch screen, file storage, right? For the out here, it can be monitor, speaker, printer, and the file storage. Okay. Now, the second thing here is the memory, right? So, talk me about nowadays when you talk about memory, normally refer to the RAM here, right? The random access memory. So, memory is the primary or main memory here. It store data and instructions that CPU need to operate. Right? So we see whatever you give the data here, right? And you need to interact from the CPU to memory. You take out the instruction here, right? You want to add them together or you want to multiply them together, you give the instruction with the memory here, right? So the store data and instructions that you need to operate. And today, if you hear about the memory, it mentioned about RAM, right? RAM is a random access memory here. And normally, if you call for hard drive here or storage here, you call it storage or secondary storage. Now that is the brain of the computer. So you look on in the diagram here. For every computer, you have the CPU. It's a central processing unit. It is the brain of the computer because it do everything about the give you instruction here, right? Do everything about instruction, about the calculation, arithmetic operation here, everything about the computer, right? That is the brain of the computer, and where instructions are executed here. And it has three main components. The first one, the control unit, right? The second one, you have arithmetic logic unit here. And the third one, you have register. Now we go one by one. What is the control unit? What is arithmetic logic unit? And what is the register here? So the first thing about register. So what is register? It is small amount stored on the CPU itself. So remember the register here, it is stored on the CPU itself. That means it works very fast because it's very closely to the CPU here, right? It works very fast. It works extremely fast because it's a proximity to the CPU component here, and every operation in the CPU involves fast moving data into and from the register. Okay, so you have some type of register here. You have memory address register. You have memory data register. You have accumulator, program counter, and current instruction register. So basically, to make it simple here, let me give you the example here, right? So think about you want to give the instruction to computer to add the two numbers, right? Numbers, sorry, yeah. Number 7 plus number 6 here. So basically, in order to give the computer to execute the addition with the 7 and 6 here, computer have a lot of things to do. The first thing here, you have to load the 7 into the CPU here, right? So how to load it? You have to tell what is the exact address here in the memory here, right? And again, you have to translate here. It is addition, not multiplication, not division here. Right? So all the thing here, it is a instruction. You need to get it. You need to get it from the register here. It tells you what action you want to do here, right? You have to load the number 7 from where? You have to load the number 6 from where? And what action you want to do with the two numbers. So all the things, they are instruction and they stored into the register here. Okay. For control unit, that is manager. That is the manager to tell you what to do here, right? That is the manager of the CPU here, and it manages a flow of data and instruction between the computer. And you have the arithmetic logic unit. It is a worker. This guy here, it is the manager, right? And he tell you what to do here. Right? So we think about, I have the number 7 here, number 6 here. Now please add them together. Right? To make it simple, think about that. This is the manager. It gives you instruction here, tell you what to do. And this is a worker, is the one who execute instruction, send it to you from the control unit. Okay? And it performs everything about arithmetic and logical operation. Right? It's arithmetic It can have addition, subtraction, multiplication, and division, and logical, and or not, and XOR here. Later on, we learn about arithmetic and logical later, not today. Right? Also, you can have the comparison here. It's greater than or not, less than or not, or equal or not. Okay. Okay, so basically, you see that is a structure of the computer here, right? You have input, you have the output, and you have the central processing unit. But how they interconnect them together, how they communicate them together, you have to use the bus here, right? The bus here, right? So what is the bus? Bus is the one who delivers information between all the components in the computer here, right? So you see, you need to communicate between the input to the CPU and between the control unit to the arithmetic logic unit, or between the resistor to the other component here, right? So in that case, you need to use the bus here. You need to use the bus. Right? So buses are the means by which data is transmitted from the one part of the computer to another here, and connecting all major internal components to the CPU and memory. And the standard CPU bus is a comprised of control bus, data bus, and address bus. Right? So basically, for the bus, it breaks it down into three categories here. The first one, control here, and the second one, address, and the third one is data bus. So address here tell you exactly where you get the data here, right? Think about, you have number 7 and number 6 here, but actually you see you store it into multiple slots in the memory here, right? You have to tell which one you want to take number 7 and which one you want to take number 6, right? And for the control bus here, it tell you what action you need to do here. Okay, and for the data bus, see, you have to carry data between the processor, memory unit, and the input and output device. Okay. Now, in order for whatever it is, right? For the computer here, you have the execute cycle here. Execute cycle here. So in the execute cycle, you have the 3 actions. The first one is the fetch, the second one is decode, and the third one is execute here. Right? So fetch, that means it will give you here. It will give it to you the information here. Right? Think about this one. I have 3 information. Right? I give it to you to the computer here, to the CPU for 3 slots here. Right? So when I get it here, I need to decode it. I need to decode it here. I translate it here. This one is number 7. Right? I translate this one here. It is a addition command here, right? And I translate this one. I have the 6 here. Right? The third one here, execute. That means I tell you that you have add number 7 to the add number 6 here. Right? So basically, for every cycle of the instruction here, you have the 3 action here. You have a fetch them, you have decode them, and you have execute here. Right? Basically, that is the way you work with the instruction cycle. Now, we mentioned about memory, right? We mentioned about memory here. So basically, the computer here, in order to store the information, they use a bit definition. The bit, what is a bit? Bit, that means you have information you can store into 1 and 0 here. And the reason it's stored in 1, 0 because in the computer you have million of switches here, right? So we think about, you have the switch here. When you turn it on, the light on. When you turn it off, light off here, right? So basically, in the computer you have million the switches. It is a electronic here, right? So basically, you work with the binary here, binary system. And the binary system here, for 1 digit, you only have the 2 states here, 0 and 1 only. Right? You can think about 1 here, that means on, and 0 here, you have off here. Okay? So if you have 1 bit, you have 2 values, 0 and 1. Now I'm asking you, if you have 2 bits, how many values you have? 2 bits. How many values you have? 4, right? You see, you can have 0, 0, 0, 1, 1, 0, and 1, 1 here. Okay, so basically, that's the formula here. If you have n bits here, if you have n bits, so in total you have 2 raised to power of n value here. Right? So in order to store information into the memory here, they use the definition of bit and byte also. 1 byte here, 1 byte, you have 8 bits. Right? So in order to store for 8 bits here, you have 2 raised to the power 8, you have 256 value. You can store into the 1 byte here. Make sense? Okay? And you have some of the unit normally you can use. Nowadays here, it is a kilobyte here. Now, you mentioned about kilo. Kilo, that means 1,000, right? Kilo, that means 1,000. But actually, in the case you work with the unit of memory here, it's not exactly 1,000. Actually, it is 2 raised to the power 10 here. So 2 raised to the power 10 is 1,024, not 1,000. So basically, when they mention about the 1 kilobyte here, actually you have 1,024 bytes, not 1,000 bytes. Right? So make sure you understand the concept here. And now you have 1 kilobyte here, and if you have 1,000 kilobyte, you have 1 megabyte, right? If you have 1,000 megabyte, you have 1 gigabyte, and so on. You have a petabyte and so on. So basically, I can show you right? So see, for this one here, right? If you have 1 kilo here, actually you have 1,024, right? So you have 1 kilo, that means you have 1,024 bytes. You have 1 megabyte here, that means you have 1,024 kilobytes, and so on. Now, if you have 1 gigabyte here, that means you have 1,034 megabytes, and so on. Right? So nowadays, you can work with the terabyte here. It's very common. So right, it's very common with terabyte here, or up before and after that, you can have the petabyte or exabyte or zettabyte and so on. Okay, and that is the case you store in the basic memory unit, right? And nowadays, in order to have the permanent storage, you can store it into HDD, or you can store it in the optical storage, or you have SSD also. Nowadays, very, very common. Now SSD, and also cloud computing here. You upload in the cloud and you can access it from anywhere. So I move to the section about the software, right? So basically for the software, it break it down into 2 categories also. The first one, application software, and the second one, the system software here. So what is the application software? That is the most common one here. I think about you using the Photoshop, you use the Microsoft Word, and so on. So what is the application software? It enhances productivity here, right? So program here, supply information, and provide entertainment here. Some of them, you can have the word processor here, database manager, spreadsheet, photo editor, and browser. That's very common here. I think about when I open the computer, you want to work with the Microsoft Word, you want to do some with the photo editing, you work the Photoshop, they are application software. The second one is a system software. So what is a system software? Sometimes they call it as operating system or firmware. I think about the Windows, about Linux, right? So what is it? They are the one who control and maintain the hardware. I told you, interface with the hardware here, right? Interface everything with hardware, about the keyboard, about the mouse, and so on in the computer here. That is an operating system here. because the main purpose of operating system is that it controls the hardware and also interface with the end user here, right? Communicate with the end user and manage and communicate with application. I think about you have some of the common system software here. You have Windows, DOS, Linux, and Unix. Okay. Now we go with the we mentioned about the programming here. Now tell me what you understand about programming. What is the programming? Programming. Now, your definition. Nothing wrong or right here. Just tell me, what do you think about programming? And what do you do with the programming?
Just a set of instructions for the computer.
Yeah, actually, it's a programming here. It gives the instruction to computer here, right? But when you give the instruction to computer, what you expect here?
Give you an answer back, solve a problem.
Yeah, actually, right. That's the purpose here. You get the instruction to computer and to solve the problem, to solve the specific problem. Okay, so I think I had the short video here to show you what is the programming. Actually, you can watch this one from the my tab.
What is a computer program? In this segment, we're going to explore the world of computer programming by looking at exactly what a computer program is. 1. You begin with problem. 2. Develop a solution. 3. Solve the problem. A computer program performs 3 functions: input, process, output. What's an algorithm? It's a step-by-step set of directions. It's very much like directions for baking a cake. You can imagine if you iced the cake prior to baking it. Each step must be logically ordered. Just like the algorithm for baking a cake, a computer program is a list of instructions that tells the computer what to do. A computer program is a solution to a problem, which consists of a set of instructions, algorithm, that tells the computer what to do. A computer program consists of input, processing, and output.
Yes. So to make it simple, right? It's a program here is a process. You give instruction to the computer to solve specific problem, right? And every program here, you have the input, you have the processing, and you have the output here. So what you do with the processing? You use the algorithm here. So what is the algorithm? It's a set of instruction here. You can think about it's an ingredient. You have the instruction. You have the step by step how we follow to solve the problem here. Okay. Now for the programming again, for the programming here, it breaks it down into the low-level language and high-level language. So what is the low-level language? Low-level language, the first thing about the low-level language, the machine language. The machine language, it actually is a language the computer ultimately working with the machine language. So what is it? Everything about 0 and 1 only, right? Because the computer underlie of every processing here, you have to convert it into 0 and 1. Right? So the machine language here is consists of only sequence of the 0 and 1. 0 and 1 here, right? And work with a specific computer here. Alright, 0 and 1 here. Now you see, if you work with the 0 and 1, everything about 0 and 1. Right? If you work with everything about 0 and 1. How about the human? It's really hard for you to understand what's going on here, right? You just see that all of the series of 0 and 1 going on here. It's really hard for you. So they upgrade into the assembly language here. So assembly language here make it a little bit of a simple for the end user here. It uses a symbolic representation of machine language. Think about instead of 0 and 1 here, you convert, it tell you have to add the A and B here. Right? So you think about the human being here. If you read about the add A and B here, way better when you read everything at 0 and 1. Right? That's one upgrade of the machine language here, and it is low-level language. So basically, remember here, whatever it is, later on you learn about Python or C or C sharp, what is it? Ultimately, you have to convert it into the machinery, right? Because when you execute program here, you have to translate it into the machinery, because that is the one computer work with the machine language here, right? So basically, to make it simple here, from the machine language, they upgrade into the assembly language here. But again, assembly language, again, it is a low level language. It's really hard for you to understand what's going on here, right? So they come up with the idea of the high level language. So what is a high level language? High level language here is to contain the English words and phrase and algebra expression here, and easier for you to learn. Easier for you to learn and use the resulting program are easier to read and modify here. And nowadays you have a lot of the high level language. You can tell the Python or C or C++, right? So I think to help you understand about the low level and high level here, I had the record. Sorry, I have a video here. It's very straightforward. Where Google. Oh, what?
A program is a set of instructions that tells a computer what to do in order to come up with a solution to a particular problem. Programs are written using a programming language. A programming language is a formal language designed to communicate instructions to a computer. There are two major types of programming languages: low-level languages and high-level languages. Low-level languages are referred to as low because they are very close to how different hardware elements of a computer actually communicate with each other. Low-level languages are machine-oriented and require extensive knowledge of computer hardware and its configuration. There are two categories of low-level languages: machine language and assembly language. Machine language, or machine code, is the only language that is directly understood by the computer, and it does not need to be translated. All instructions use binary notation and are a language that is
So you mentioned it, right? It's a language directly understood by the computer and do not need translating, because everything 0 1, right?
directly understood by the computer, and it does not need to be translated. All instructions use binary notation and are written as a string of ones and zeros. A program instruction in machine language may look something like this. Technically speaking, this is the only language computer hardware understands. However, binary notation is very difficult for humans to understand. This is where assembly languages come in. An assembly language is the first step to improve programming structure and make machine language more readable by humans. An assembly language consists of a set of symbols and letters. A translator is required to translate the assembly language to machine language. This translator program is called the assembler. It can be called the second generation language since it no longer uses ones and zeros to write instructions, but terms like move, add, sub, and end. Many of the earliest computer programs were written in assembly languages. Most programmers today don't use assembly languages very often, but they are still used for applications like operating systems of electronic devices and technical applications, which use very precise timing or optimization of computer resources. While easier than machine code, assembly languages are still pretty difficult to understand. This is why high-level languages have been developed. A high-level language is a programming language that uses English and mathematical symbols, like plus, minus, percent, and many others, in its instructions. When using the term programming languages, most people are actually referring to high-level languages. High-level languages are the languages most often used by programmers to write programs. Examples of high-level languages are C++, Fortran, Java, and Python. To get a flavor of what a high-level language actually looks like, consider an ATM machine where someone wants to make a withdrawal of $100. This amount needs to be compared to the account balance to make sure there are enough funds. The instruction in a high-level computer language would look something like this. X equals 100. If balance less than X, print insufficient balance, else, print please take your money. This is not exactly how real people communicate, but it is much easier to follow than a series of ones and zeros in binary code. There are a number of advantages to high-level languages. The first advantage is that high-level languages are much closer to the logic of a human language. A high-level language uses a set of rules that dictate how words and symbols can be put together to form a program. Learning a high-level language is not unlike learning another human language. You need to learn vocabulary and grammar so you can make sentences. To learn a programming language, you need to learn commands, syntax, and logic, which correspond closely to vocabulary and grammar. The second advantage is that the code of most high-level languages is portable, and the same code can run on different hardware. Both machine code and assembly languages are hardware-specific and not portable. This means that the machine code used to run a program on one specific computer needs to be modified to run on another computer. Portable code in a high-level language can run on multiple computer systems without modification. However, modifications to code in high-level languages may be necessary because of the operating system. For example, programs written for Windows typically don't run on a Mac. A high-level language cannot be understood directly by a computer, and it needs to be translated into machine code. There are two ways to do this, and they are related to how the program is executed. A high-level language can be compiled or interpreted. A compiler is a computer program that translates a program written in a high-level language to the machine language of a computer. The high-level program is referred to as the source code. A typical computer program processes some type of input data to produce output data. The compiler is used to translate source code into machine code or compiled code. This does not yet use any of the input data. When the compiled code is executed, referred to as running the program processes the input data to produce the desired output. When using a compiler, the entire source code needs to be compiled before the program can be executed. The resulting machine code is typically a compiled file, such as a file with an exe extension. Once you have a compiled file, you can run the program over and over again without having to compile it again. If you have multiple inputs that require processing, you run the compiled code as many times as needed. An interpreter is a computer program that simulates a computer that understands a high-level language. This means that the interpreter translates the source code line by line during execution. Consider again a computer program that processes some type of input data to produce output data. The interpreter executes the code line by line, which results in the desired output data. The only result is the output data. There is no compiled code. When using an interpreter, every time you want to run the program, you need to interpret the code again, line by line. There is no compiled code to use if you have multiple inputs that require processing. To understand the difference between compiling and interpreting, let's examine the equivalent in human languages. For example, consider a movie made in Asia where all the characters speak Vietnamese. To market the movie to an international audience, the spoken text needs to be translated into English. A translator would sit down and carefully translate all the text and create subtitles for the movie. Anytime someone wants to watch the movie, they can turn on the subtitles. This type of translation is the equivalent of compiling. Everything is translated once and can be used many times afterwards. Now consider a delegate from Vietnam giving a speech in the United Nations in Vietnamese. In order for the attendees to understand the speech, there are a number of translators who provide a translation that is transmitted to the attendees' headphones. This translation occurs close to real time. Every time the delegate speaks in Vietnamese, the translators get to work. This type of translation is the equivalent of interpreting. Text is translated line by line as necessary, and the results are not used again. Compiled code tends to be faster since the translation is completed in one step prior to the actual execution. Interpreted code, on the other hand, is more flexible and can be run interactively. For example, using interpreted code, you can try out a few lines of code to see if they work very quickly without having to go through the steps of compiling and executing the program. One advantage of using compiled code is that it does not reveal the original source code. This makes it possible to distribute a program without revealing its inner workings. When you install a software application on your computer, you are typically installing a compiled version of the code. You can run the software application, but you can't open up the source code in the original programming language. For many companies selling software applications, the original source code is a well-kept secret and gives them their competitive advantage over other companies. Examples of compiled languages include C and its derivatives, C++, and C#, COBOL, and Fortran. Examples of interpreted languages are Java, Perl, Python, and Ruby.
And like the way they explain between the compiler, like very straightforward, right? Or think about you make the you have the film and you want to do the subtitle for one story, right? But you can show the film again and again using that subtitle. That's the way you work the compiler, right? But the interpreter here, you have every time he speaks one sentence, you have to translate it and so on. Okay. So you know the difference between about the low level language and high level language here. Now tell me, what do you think about what are the pros and cons of the low level and high level language? So for the pro of the low level language, what is it? Now talking about the low level language, what is the benefits? What's the pro? What is the con?
Pro is probably that it's automatically read by the computer.
Yes, because it's a machine language, right? Anything else? You do not have to translate it. And that works very fast. Right? It works very fast. You do not have to translate it here. It works very fast with low level because everything 0 1. Anything else?
Con. It's device specific.
Yeah, right. It's device specific because you have to totally understand about the hardware here because it's designed for the hardware specific, right? So when you move from the 1 to 1 here, you have to modify it. Okay. Now for the high level language, what do we think? What is the pro and con?
Easier to understand.
Yes, sure, right? It's the same with the human language here. Anything else? That is the pro and con.
It has to be translated.
Yeah, you have to translate it, right? It's not very fast. And also for the pro here, it's easy to understand and it's portable. That means you can move from one computer to another computer. You do not have to modify it, right? Yes, you have some specific pro and con for each of them. So I think you guys should take a short break for 5 minutes and we come back. Okay, so you know the process of programming, right? Programming, that means you give the instruction to computer to solve the specific problem here, right? So that's the process you make the program. So basically, in order to make a program, think about I give you very simple program here, right? I give you that. Tell me, I give you the very specific program here. I'm asking you that you have to figure out area, a rectangle. So what I think, I'm asking you to figure out the area of rectangle. So what do you need in order to figure out the area of rectangle? What do you need? Formula. Anything else?
The dimensions.
Yeah, right. Of course, they are input. They are input here, right? So basically here, for every program here, if you want to do a specific program, the first step is very important. Understand the problem. What you are supposed to do. What are you supposed to do here, right? Now, think about this one. Think about this, my program here, right? So think about, I'm asking you to do this process here. Asking you to do the process here. Make me some cookies. Now tell me, what you are supposed to do to make me some cookies. Now tell me.
You need to get ingredients. You need to have a recipe.
Anything else?
Deliver you the cookies.
Know how many.
Yeah. Actually, that is very important. Right? Even that for every simple program here, the first step here, you have to deeply understand the program. Now I'm asking you to make me some cookies. How many? You have very specific here, right? Think about later on here, you give me 5. No, I want 100 here. So again, you have to run to the Kroger to buy the stuff again and do it again here. That is the first step. But it's very important for every program here. Understand the problem here. Now think about make me some cookie here. Actually, you have to be very specific about my demand here, my requirement here, right? How many? How many, right? Do you want chocolate or not? You want crunchy or not? and so on here. I think about it here. If you do not specific about requirement here, I'm specific about 100 is okay here, and now you rush to the Kroger and you buy every stuff here. You make it, but later on, no, I don't like this one. I like the crunchy one here. Again, you have to buy it again and rush to the Kroger again and buy stuff here, right? So basically, the first step in every program here is understanding program. You can take it easy, but it's very important, right? Because you can think about you have you sign a contract here, right? To tell you with someone to tell you that you have to deliver me for 100 cookie here. You have to very specific about this one, right? The more detail you have, the later on you have the success here in the program here. And later on, I see. Otherwise, you have to fix something and go back to fix it, right? So basically, in the life cycle here, right? So every program life cycle here, you can see, they tell it's a life cycle because at any step, you have some problem here, you have to come back to fix it, right? So basically, for every program here, and even with a small program, with a very simple program here, you also have to follow step here. Understand program. It's very important. It's very important here, right? And later on, you plan the logic. You tell me, right? You have to specific about the instruction here, about ingredient here, how many eggs, how many milk, and so on here, right? Think about in order to 100 cookie here, I need 2 can milk and I need 10 eggs and so on here. I have to very specific about the plan logic here. And actually, the write the code here, it requires simple. You just follow the instruction you do here, right? So the two most important steps in the development cycle here, understanding problem and the plan logic. Actually, very important step here, right? So you have more time, it's more specific, and more effort is spent on the understanding problem and plan logic. Then later on, you have more success rate of your program here, right? Actually, the write code is very simple. You just follow the instruction and you convert it into the specific programming language here, right? And later on, when you learn about pseudocode or when you learn about flowchart here, when you look into the logic of flowchart of pseudocode, you can easily convert it into the Python, right? So understand problem here, plan the logic, write the code here. Now translate the code. That is a concept you learned already, right? You do the compiler or interpreter here, right? So now when you have output here, you have to make sure that is what you expected here, right? That's what expected here. Think about I want you to write the program to figure out the area of a rectangle, right? So I give you the length here, it's a number 10, and the width here is number 5. So I expect here it is a 50 in the output here. So I have to make sure the output is what I expected here, right? Okay, and again, when you're done with the program here, you can put it into the in production here, but you have not done it yet. Even that when you put into the production here, you have to follow up, right? You have to see what is the feedback of the customer here, of the end user here, and now you have to maintain program, right? And that is a circle. That is a cycle here, because at any step, if anything goes wrong or anything come up, you have to come back to fix it. Okay? So that's why I mentioned that even that with a simple program here, you have to be very specific about the understanding problem and the plan logic here. Think about, okay, come back to my example here. I give you the program here, you have to figure out the area here. A rectangle. Right, so what do you do with the understanding problem? What do you think? What do you do with the understanding problem of this one? What step you need to do in the understanding problem here? Understand problem.
Length and the width.
Yes, length and the width, and anything.
Formula for the area of the rectangle.
So basically, for understand problem here, yeah, that is a step you identify what are the expected output here. All right. So for sure, for this one, I need area here. Right? That's expected output. So from expected output here, I can figure out what do I need in order to figure out area here, right? So I know that in order to figure out area of a rectangle, I need dimension here. It's the same with my problem here. I need that is my expected output 100 cookies here. And also I have very specific, it's crunchy and I have the chocolate chip and so on. So we know that that is my expected output. So from that you have to figure out what do I need in order to make it up for the 100 cookie here, right? How many milk, how many egg, and so on. Right? So basically in the process of understand problem here, the first step for sure, you have to be very specific about what is the expected output. Right? From the expected output, you can figure out what do I need in order to deliver for expected output here. Okay? And the plan logic here, you have to put out the formula or instruction here, right? For this one, quite simple here. You just come together. But for this one, you have to list it out step by step, right? You have to mix the flour and crack the egg and so on here, right? Okay. So basically, yeah, the step in understand problem. The first step for sure, you have to be very specific about what do you want from the output of this program. And from that one, you have to figure out what are the input you need in order to deliver expected output here. Okay. Okay, so no, I don't think this one here. Okay, so we mentioned about the cycle here, understand problem here. Now we move to the plan logic. Plan logic here, that means you list it down all the instruction, right? And what you are supposed to do. And in the case of the plan logic here, you use the algorithm. Algorithm, what is it? Algorithm, it is a step or the rule you have to follow to solve the problem here. Okay? So that's a solved problem here. So I think you have
I don't like writing essays, but here are my marks for them. So bestie, I'm going to tell it to you straight. Personally, I prefer using Grammarly.
What's an algorithm? In computer science, an algorithm is a set of instructions for solving some problem, step by step. Typically, algorithms are executed by computers, but we humans have algorithms as well. For instance, how would you go about counting the number of people in a room? Well, if you're like me, you'd probably point at each person, one at a time, and count up from 0. 1, 2, 3, 4, and so forth. Well, that's an algorithm. In fact, let's try to express it a bit more formally in pseudocode, English-like syntax that resembles a programming language. Let n equal 0. For each person in room, set n equal to n plus 1. How to interpret this pseudocode? Well, line 1 declares, so to speak, a variable called n and initializes its value to 0. This just means that at the beginning of our algorithm, the thing with which we're counting has a value of 0. After all, before we start counting, we haven't counted anything yet. Calling this variable n is just a convention. I could have called it most anything. Now, line 2 demarks the start of a loop, a sequence of steps that will repeat some number of times. So in our example, the step we're taking is counting people in the room. Beneath line 2 is line 3, which describes exactly how we'll go about counting. The indentation implies that it's line 3 that will repeat. So what the pseudocode is saying is that after starting at 0, for each person in the room, we'll increase n by 1. Now, is this algorithm correct? Well, let's bang on it a bit. Does it work if there are 2 people in the room? Let's see. In line 1, we initialize n to 0. For each of these 2 people, we then increment n by 1. So on the first trip through the loop, we update n from 0 to 1. On the second trip through that same loop, we update n from 1 to 2. And so, by this algorithm's end, n is 2, which indeed matches the number of people in the room. So far, so good. How about a corner case, though? Suppose that there are 0 people in the room, besides me, who's doing the counting. In line 1, we again initialize n to 0. This time, though, line 3 doesn't execute at all, since there isn't a person in the room, and so n remains 0, which indeed matches the number of people in the room. Pretty simple, right? But counting people one at a time is pretty inefficient too, no? Surely we can do better. Why not count 2 people at a time? Instead of counting 1, 2, 3, 4, 5, 6, 7, 8, and so forth, why not count 2, 4, 6, 8, and so on? It even sounds faster, and it surely is. Let's express this optimization in pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. Pretty simple change, right? Rather than count people one at a time, we instead count them two at a time. This algorithm does twice as fast as the last. But is it correct? Let's see. Does it work if there are 2 people in the room? In line 1, we initialize n to 0. For that one pair of people, we then increment n by 2. And so by this algorithm's end, n is 2, which indeed matches the number of people in the room. Suppose next that there are 0 people in the room. In line 1, we initialize n to 0. As before, line 3 doesn't execute at all since there aren't any pairs of people in the room. And so n remains 0, which indeed matches the number of people in the room. But what if there are 3 people in the room? How does this algorithm fare? Let's see. In line 1, we initialize n to 0. For a pair of those people, we then increment n by 2. But then what? There isn't another full pair of people in the room, so line 2 no longer applies. And so by this algorithm's end, n is still 2, which isn't correct. Indeed, this algorithm is said to be buggy because it has a mistake. Let's redress with some new pseudocode. Let n equal 0. For each pair of people in room, set n equal to n plus 2. If one person remains unpaired, set n equal to n plus 1. To solve this particular problem, we've introduced in line 4 a condition, otherwise known as a branch, that only executes if there's one person we could not pair with another. And so now, whether there's 1 or 3 or any odd number of people in the room, this algorithm will now count them. Can we do even better? Well, we could count in 3s or 4s or even 5s and 10s, but beyond that it's going to get a little bit difficult to point. At the end of the day, whether executed by computers or humans, algorithms are just a set of instructions with which to solve problems. These were just 3. What problem would you solve with an algorithm?
So that is instruction. Sorry, algorithm, right? It's a set of the instruction to solve specific problem here. Okay. So now come back to the slide here. You know that you have understand problem. You plan the logic, right? The plan logic is that where we set for the algorithm here to solve the problem, right? And the write the code, that means you translate it into the specific programming language. It can be the Python or C or whatever it is, right? And when you translate it here, that means you do the compiling here or interpreting here, right? Okay. And yeah. So basically, when you translate the program into the machine language here, right? So normally you have to follow the syntax. Each of the programming, they have specific syntax here, right? Think about, in the case I work with the Python here. In the case I work with the Python here. Think about, I want to assign the value of number 10 to the variable name x here, right? So I have to put the variable name on the left and the value I want to assign on the right here, right? But for some mistake here, I put number 10 equal x here. You can see what happened. You have the syntax error here because you cannot assign number 10 to the x here, right? If you want to assign the value to a specific variable, you have to put the variable on the left and the value on the right here. That is the syntax. So for each of the programming language, they have specific syntax here, and you have to follow the syntax here, right? And it's specific on programming language. Okay, so basically, when you run the program here, right? Sometimes you can have the logical error also. So now talk about the syntax error. I think I have something here. No, anyway, okay. Now remember the syntax error when you write the program here, right? When you translate, sorry, when you compile program here, if the syntax error, that means the program stop, cannot execute it, and you are the one who has to find out where the error is, and you have to fix the problem here. Otherwise, the program is not executable here, right? The other error of the program here is the logical error. So the logical error here, when you execute it, it's executed here, right? but the output is not what you expected. Now think about this one. Think about I want to find out what is I have the two number here, number 5 and number 6 here, right? So I want to find out what is the addition of the two number here. So I expect here is number 11 here. Right? I expect that here is the number 11 here, but somehow in my programming here, instead of putting the addition here, I put multiplication here. Right? So see, when I execute my program here, it prints out number 30. That is not what I expected. Right? So basically, the logical error here, when you execute program, it works well, but the output is not what you expected here. Right? So basically, you only able to find the logical error by the testing here. You have to set it out all of the testing scenario here, right? What you expected here, and so on here. Okay, so as a step here, you have to put into introduction, maintain program here, and so on here. Now, so I think so all of the thing about the definition here now, I want to give you some of the activity here, right? So just to sum it up for every program here, right? You have every program here, you have the three basic elements. You have the three basic elements for every program. Input, you give the input, right? Input here, you get input from user, or it can be from file or database, whatever it is. Processing here, you follow the instruction, you set it up for algorithm here, you follow instruction here, do everything with the calculation and processing, right? And the output, I give you out the desired output here. Now think about this one. I have the very simple program here, right? A program that prompts the user to enter a number, calculate its double, and then display the result here. Now think about this one. I have requirement here for my program. Right? I have programs that prompt the user to enter the number, calculate its double, and then display the result. Now the first step in the cycle here, I want you to understand the problem. So the first step in the understand problem here, you have to find out what is the output, what is the exact output here, and what are input here. So what do you think about this one? What is input and what's output for this one? For this program? For this program, what do you think? I think about I asking you to enter number 10, and I just double it, I bring it out number. Okay? Now, for the program that prompts the user to enter a number, calculate it double, and then display the result here. What do you think? What are the input and output for this one here?
Input is the number. User enters the program.
Okay, the input here is the number, right? And the output, double of that number, right? So basically, this very simple program, you only need two variables here. Okay, later on, I explain what is a variable here, right? Variable, that means something is changeable. Variable, that means vary, right? That's changeable here. So think about this one here. So what you do with the variable? Like, I think it should be better. I explain the concept of the variable first. Right? The variable here. The first thing you have to understand the variable, they are name memory relation. So think about this one. I have number here. I put the variable name is number. So actually, it is somewhere in my memory. Right? So you see in memory here, I have a lot of the slot here. I have a lot of slot in memory here, right? So when you have number here, it take it out somewhere in the memory. Right? That's why variable are name memory location. The thing about I put it number here and I give it the value of number 10 here. So what happened? Actually, the slot here with the name is a number. Right? The slot here with the name is number. And the value I stored into the slot here, number 10. Okay? But remember here, the value here, it can be differ over time here. So we see, right now I assign number 10 to the number here, but later on, I can change it to the number 20 or 30 or 40 here because it is changeable. Right? And remember, whenever you have new value, it will override the old value. Right? To think about this one. I do the simulation in the Python here. Okay, think about this one in the Python. So if I have number 10 here, That means I give the value number 10. I assign it to the variable x here. Right? So now I can print it out. What is x here? I have number 10. Right? And now later on, I want to change the value of x. I change it to the number 20 here. I change it to number 20 here. And you see, I have the same name, it's variable here, but now value it is the number 20 here. Right? Because it's changeable. Now, if I put y here equal x plus x here. Right? That means I give y equal to x plus x, and I want to print it out x here. What do you think? Sorry, I want to print it out y here. What do you think? What's the value of y?
40.
What do you think? Sorry, I should be better. I do. Okay, now I print it out y here. What do you think? What's the value of y? 40, right? Yeah, because the reason here, you see, the reason here, you can see about the program here, right? Now what happened here? I have the variable x here in the memory, the name of x here, right? So what is it? The first step here, I assign number 10 here. I assign number 10 here, and the process here, I want to print it out. That means I accept in the memory name x here, I take it as a value, right? And I print out number 10 here. So the next step here, I assign x to the 20 here. That means I assign number 20, but remember the new one is override the old one here. All right? So now I take it y equal x plus x here. So what is it? You take it out in memory, name x here, take it out value number 20 here, and again this one, take it out value number 20 here, and do the processing. I have 40. Right? So that's the variable. Remember the variable is something is changeable. And it's a name memory. It's name memory in the slot here, right? In the memory. Okay, so now about the definition of variable, right? They are name memory location. They are name memory location here, and content can vary or differ over time. And remember, variable name they are case sensitive, right? So you think about again for this one here, right? Again, for my program here, I have x here, right? But somehow I want to print it out x, but by mistake here, I put it capital X here. You see, I have error here because they are program here try to look it up for the memory with the capital X here, but I don't have anything. Right? That's why I have the syntax error here. So remember, the variable is a case sensitive. You have to pay attention when you work with the programming here. What else? Right? And you have something about the variable name. You have some specific rule here. It must be one word only. Right? So think about. I'm asking you that to get the monthly income from the user here, right? You store it into the monthly here. Income here. It will not accept it because you have the space here, right? So make sure that when you use a variable here, it's one word only. So we can put underscore whatever it is to make it one word, right? To make it one word here, and it must start with a letter. So think about 1 month here. It's not accepted because it's starting with the number here, okay? And somehow here, and also it should be better. It should be better you use some appropriate meaning, right? So of course, for me, I give it the x and y or z here. I make it simple, but later on, you see you have very complicated program. It's really easy for you to see what's going on by naming the meaningful variable name here, right? So we see it is a state tag or federal tag or so on. Okay, so come back to the slide here, right? So we know that the first process in the software development cycle is the understand problem here. And what you do with the understand problem, you identify what is the output and what's the input here. That's the first step, right? You know what you expected from the program. That is the output. And in order to deliver that output here, what are the input you need here, right? So think about this one here, a program that prompt user to enter the length and the height of rectangle. I see what is input. Output here is area. And in order to figure out area, you need the length and the width here, okay? Now, so when you got the input, right? When you got the input here, you have to do the calculation. You have to do the processing here, right? So what you do with the processing? You use the operator here. You use the operator here. They are symbols that perform operation on value here, right? And you have some specific operator here. The first one is assignment operator. That's what I did it to you, right? So that means when I put x here, number 2 here, that is the process of assignment here. I give the value number 2 to variable name x here. So remember, in the case of assignment here, you have to put the variable on the left, right? And the value on the right. Okay, that's the first thing. And also you can do with arithmetic operator here. Add them together, subtract them, right? Multiply them together, divide them together, divide them and take out the integer part only, right? Modular here and exponential here. Right? Think about I do this one here, right? I do one by one here. So you see you have some of arithmetic operator here in the Python. I think about I have x equal to number 11 here, right? And that is a process of assignment, right? That is the process of assignment here. Now I do the addition, right? I have y equal to x plus 5, right? So I bring it 1, I have 16 here, right? Or I have y equal to x times 2, I have y here, number 22 here, right? Or I can have subtraction here, right? Y is x minus 5, I have y here, number 6 here. And you have some other thing here. You divide, right? Think about you have divide here. You have y x divided by 2, right? And you have y here, right? But if you want to integer part only, you can have y. Sorry, you have y x here by 2. You have y. You have number 5 over here, right? That is the integer part. Or you can work the modular, that means remainder here, right? Think about we have y, you have x, and modular here. Number 2, what do you think? What I have for y here? If I have x is 11, right? And I modular number 2 here, what do you think? What I have for y? If here number, the remainder. 11 divided by 2, what is the remainder? Number 1, right? Number 1, right? So see, you have number 1. So that is the process. Later on, that is the process you figure out number is an even or odd number. Right? Even number, that means when you modular 2, you have no remaining. Right? And the odd number, when you modular 2, you have 1 remaining here. Right? So later on, when you learn about the decision, you can check if number is an odd or even number. Okay, and also you have the comparison here, right? Comparison operator. So remember here, one thing, some of you, the common mistake for some of you here. Right? So if you want to do the comparison, if they are equal here, you have to use double equal sign, not only one single one. Single one is the assignment. Right? So see, x equal number 10 here, that means you assign value number 10 to x here. But if you want to check if x is equal to number 10 or not, you have to use a double equal sign. Right? Okay? And so on. So you can see, we will check it here. I think about this one, right? So now I have x number 11, right? I check if x equal to number 10 or not. I put it here, it's 4. Right? So the output of the comparison is always 4 or 2 only. 4 or 2 only, right? It's 4 or 2 only. So think if x here greater than 15 or not, 4, right? X less than 20 or not, 2, and so on. Right? And also one more here, x is not equal to 11 or not. What do you think? What I have here? 4, right? Because I hit a number here, right? Sorry, not this one. I hit 4, right? Because it is 11. Okay, so you have some operator, right? The first one, assignment operator. You have arithmetic operator. You have comparison operator. You have logical operator also. And or and not later on when we learn about the logic gate, and we learn about the truth table, I explain it here. And of course, you have order of operation. You have order of operation here. So for arithmetic order of operation here, right? Everything inside the parenthesis, you have the first priority. Right? So if you have a lot of things to do here, make sure that you have to do everything inside the parenthesis, right? And the next one, it is exponent here. That is the exponent here, right? There's the exponent here. That's the second priority. The third one, you have multiplication, division, modular. They're the same. And the last one, you have the addition and subtraction here. Sorry, number 4. And last thing, you have the assignment, right? So think about this one here. I give you the example here. I give you the example for this one. Now tell me what is the value number x here? How we do it? How do the processing here? And what is a step you find out? What do you think? What is the x here?
First time we lose 32 divided by 4. Inside the parentheses.
Right? So see, the first step for sure you have to handle everything inside parentheses, right? And of course, you see in this one here, this one is division here, right? And this one addition here. This one has the higher priority, right? That's why you have to take it out. This one here, 8 here, and then the on you 12 here, and you put it inside the parentheses here, right? And now I simply write here number 9 minus 9 modulo number 2 here. Right? So now inside the parentheses, you have the 8 plus 12 here, you have 20. Right? If you divide by 5, you have number 4 here. Right? That's why you have number 4 here. And you minus 9 modulo 2 here. So again, you see, you have subtraction here, and you have modulo here. And remember, modulo, you have higher priority here. Right? So basically, you have to do this next here. So you have 4 minus 9 modulo 2, what do you have? 1. You have 1 remainder. So the output of this one is number 3. And last thing here, I do assignment. So now I have x equal to value of 3. Okay? Yeah, so I mentioned about syntax error, right? Syntax error is that means it cannot execute program, right? Syntax is a specific rule and structure, and each programming language it has its own syntax here. Logical error, program reduce, execute it, but it produces incorrect output here, right? That's what I mentioned here. Okay, so now come back to the software development cycle here, right? You understand problem, identify what is the input, what's the output, and so on here. Plan the logic. That means you have to build it up for the instruction here, right? About the instruction, about algorithm here. Right? So basically, in the process of plan logic here, normally you have to work this one here. In this class, you learn about the process of pseudocode or flowchart. So what is pseudocode? Pseudocode is a fake code. Remember, it's fake. It's not real programming language. Right? It's a fake. It is English-like representation of logical step it takes to solve the problem. And the flowchart is a pictorial representation of logical step it takes to solve problem. So that is a two way you can work in the case of the plan logic here. Right? So when you do the plan logic with the pseudocode or flowchart here, later on you can translate it into the real programming language here. Right? So now you're writing the pseudocode here, right? Pseudocode, you think about the program here. I mentioned it before. I need to get the number from user. I need to get one number from user, and I just double that number, and I want to print it out. So how we write it in the pseudocode? Remember, in the case pseudocode here, every program you have start and stop here, or sometimes it ends. Okay, right? Start and stop. Remember that, right? You have start and stop here. Now that is that is outside of the program here, right? So everything here, you have to. The first step I expect you to do is that you have to pay attention to indentation. Right? So you see, start and stop here, it's an outer level of the program. And everything in the body between the start and stop, you have indent at least one level. Right? The indentation to make the program structure and very easy for you to follow up. Right? So this one, you know that in the program here. Present the number double program here. You know that in order to do that, in order to figure out the double number, you need a number. That's why you need a number here. So what is it? That is a variable. Because sometimes I enter number 10, 20, or 25, or so on. This is process. It is a variable here. And the input here is a keyword. That is keyword. You need to get it from user. Right? So the input here tell user enter a number. Right? That tell user enter the number. So now when I get the number, right, I store into the variable. Its name is my number here. My number. I start into my number, and it depends on the end user, right? Sometimes he enter number 20 or 20 or whatever it is. It's variable, right? So now when I got it, what is it? I just double it here. So what is it? That is the process of the processing of calculation here. And so what is, when you look on this one here, you know that you have to execute on the right first. That is assignment. You have to execute on the right. So what is it? The program look it up in the my number here. I look it up in the variable. Take it out the value here. If I store number 20 here, take it out number 20 and do the calculation. 2, I have 40. Now what is 40? I assign it to the my answer. So what is it? That means I create one more slot in the memory. One more slot in memory, and the memory slot here, the name is my answer. My answer here. My answer here, and it gives the number 40 to this one. And later on here, I just print it out the output. That's the keyword. So what is it? I access into the memory with the name my answer, and take it out value and print it out. Okay, so this one you can work with. You can work with the Python here, or you can work with the here. This one work with the Python, right? You don't have to work with the Python right now, but I just want to show you how to work with Python. So in the case you work with the pseudocode, or in the case you work with the Python here, right? If you want, you work with new file here. That is a script mode, right? So you have my number, right? My number. In the Python, you have to, again, you have the keyword here, input here. Right? Is a put it here. Right now, I don't want to do the prompts, and later on I explain to you. It's very important to get the prompt here, and again, also you have to convert it into the integer mode here. Now, I'm doing the Python here, but right now I'm not required to do the Python. It's up to you. It's optional. You do not have to understand the Python right now. Right? You do not have to understand Python now here. So I have my answer here. And I give it to my number. Have to here because I want to double it. And now in the Python, if I want to print it out, I use the keyword print here. Print here. And my answer here. Okay, that's all. That's a very simple program for this one. So in this one, if I want to run it, I click the run here. Right? I can run the module here. I have to save it somewhere. I want to save it to desktop here. That's it. Okay, now you see this. I supposed to enter the number here, right? So if I enter the number 10 here, it prints out number 20 here, right? So that is the case you work with the Python in the script mode. It's script mode here. Now, but right now I'm not required to do with the Python. You just understand the concept when you get the input and the output with the pseudocode here. Now come back to my pseudocode here. Right? So this, for now I expect that whenever you do any pseudocode program here, you need to start and stop. You need to use indentation. Indentation for at least one level because it helps you structure program here. And later on, when you learn about the decision, about the loop, and so on, you need to indent to one more level here also. Right? Okay, that is process. You get input. That is the process. You do the processing, and that is the process. You do the output here. Right? This is very simple program. You need to get input. You need to double it, and you just print it out here. It's very simple program, right? But later on, you expect that you can do it more with the pseudocode here. So I think it's a 120 now. I have to stop it here. Any question? Let me know. Or any recommendation or any feedback? Let me know. What do I need to improve my lesson, my structure, or my slide? Let me know. Any feedback or any recommendation or suggestion from you? I welcome. Anything good?
It's good.
Okay. So let me check attendance here. Honestly, I'm not really sure. I remember all of your name here, so it should be better. I have to check it or before I know what's your name. It's all right.
Just yes.
That's in here. No. What's your name?
Charles.
Okay, Charles. Yeah. What's your name?
James.
Last one. Yeah. What's your name again?
James.
James Wilson.
This one? Yeah. Okay. Hello, I have Emily here. Okay. I have John. And I have Becky. Okay, so I see you on Wednesday, and on Wednesday you expect to have more hands-on activity because today I spent a lot of time to explain about the policy and so on here. But on Wednesday, hopefully you have more activity to work with pseudocode and flowchart and Python also. Okay, so I see you on Wednesday, and make sure that when you go home, you download Draw.io, install Draw.io, download the Python, and install Python and so on. Okay. Okay, so I see you on Wednesday.
Thank you, sir.
Bye-bye.
Thank you.
Have a good one.
Bye.
Good day. And
You know what's your name? I
Me?
see. Yeah, you just joined the class,
Oh, what?
right?
It is Micah.
Because this class starting at 11 and ending
Yeah,
now.
yes, sir.
What is the reason you joined the class so late?
I had other things to attend to. I'm sorry about that.
Okay, so I see you guys on Wednesday. Okay. Class end now and
Yes.
one. Okay, so see you on Wednesday.
Okay.